My name is Charles DeBeck. I'm with Google Cloud Threat Intelligence. We're going to be talking a little bit today about serverless security and some of the ways you can help protect your serverless apps and some of the threats that we're seeing, as well as kind of the broader threat landscape around cloud. I know the formal structure here is to do a Q&A at the end, but if you have a question in the middle and you want to just shout it out or you want to raise your hand, feel free to do so. I'm certainly happy to answer questions as we go. Because I don't know, I kind of like this to be a back and forth rather than me just talking at you for 30 to 45 minutes, but you know, we can do whatever everyone likes. Give me 1 second here to get this worked out. Nope, that wasn't it. Oh, the big green button, like you said. We got there, okay. So before we jump into serverless security, let's talk a little bit about cloud in general and the role of serverless so we can kind of just level set across the board. Obviously, cloud services provide a lot of benefits for organizations, right? Scaling capabilities, the ability to build out and have tremendous on-demand scaling is really useful for organizations that don't know when they're going to need to scale up or scale down, or that have variable scaling over time, so you're not always paying for a certain amount of scale. You can sort of do that at a variable rate. This should hopefully be pretty obvious to everyone in this room because you're all obviously professionals in this space. Serverless does the same thing for application hosting. It's very cost effective. It's a great way, if you have an application that you don't know how much it's going to be used, for you to be able to sort of abstract away the underlying infrastructure and gain cost efficiencies. Super easy to use based on that abstraction, and you have a lot more consistent uptime when you're using something like this because you don't have to worry about any of the underlying layers. So in general, serverless, pretty useful. But there are threat implications to using serverless apps as well that we're going to talk a little bit more about. Before we get into sort of the modern threat landscape, let's take a step back and look at what the history is in this space, which is very limited, in fact. When we think about serverless security, you know, we've been using serverless apps for a long time, but this space is generally pretty understudied. There hasn't been a lot of work or research in this space. One of the only reported instances of malware specifically targeting the serverless area is something actually called Denonia. I'm going to note that there is a misspelling here. Deponia is actually a video game. The malware is Denonia with an N instead of a P. So if you're taking notes, please don't blame the video game, please get the malware. Also, hat tip to Cato Security. This was one of their great finds that they published on, so I didn't actually cite them on this slide. That was my fault, my apologies to Cato Security, but they did really great research here. The Denonia crypto miner was interesting because what it essentially was a crypto miner, a pretty classic XM rig crypto miner that was wrapped in a way to be able to take advantage of AWS's Lambda compute service. There's a lot of unknowns in this particular instance. We don't really know who was behind this, if this was just a general criminal actor. We also don't know why they didn't make more iterations on this after it was published on. This is one of the few instances where we saw crypto miners really pushing up into Lambda's space, and we haven't seen much publication since. I think this is interesting because we don't often see threat actors try something once and then just sort of walk away from it, which suggests to me that rather than this being one thing they tried and just said, never mind, we're done. More likely, this is more of a visibility gap where there is still continued activity in this space, but we're not necessarily looking for it because it's not something that's super common compared to a lot of other threat activity that we see. In general, this is a relatively understudied field. I think that people aren't really too concerned about serverless, and I think part of this derives from the fact that everybody thinks it's the other person's problem. I think that generally users think, oh, well, the provider's obviously going to take care of this because we've abstracted away everything underneath. So what are we worried about? Why do we even have to be concerned about this? And on the provider side, this is something where you might say, oh, well, obviously if a client sees something happening here where they see unexpected compute resources being used up, surely they'll say something or surely they'll have an alert trigger, so that's going to come to our attention one way or the other. So this sort of pointing fingers both directions ends up with another reason for this gap in visibility and why it's something that I think that we need to be concerned about as security professionals. Okay, so why does this matter? Well, I think we're going to continue to see an increase in serverless usage over time here. In general, when it comes to serverless for organizations, more and more organizations are seeing the advantages to being able to abstract away a lot of this underlying infrastructure, and this is just going to be a growing area for organizations. Serverless infections, though, can lead to pretty significant downstream impacts. If you're hosting business-critical applications in a serverless environment and there is an infection there, then you could have significant impacts to your organization pretty obviously. It can halt business operations. It can also cause lateral movement into other components of your environment, which could cause more downstream impacts. In general, the risk here is if this is being used as an initial infection vector and you're not observing that or looking for that, there's a risk that then you won't be able to stop something sooner in the overall infection process. Additionally, the scaling capabilities of serverless can create outsized risk or harm. The main point here is if you think about serverless, it has the ability to scale up very, very quickly. If you're talking about an infection that takes advantage of scaling or takes advantage of high levels of compute resources, like a crypto miner, the amount of damage or harm it can cause can be very significant in a very short period of time, where we could see a very significant ramp up without a lot of warning. See next slide. So these are two graphs that are taken from the Threat Horizons report. This is a report that Google Cloud puts out on a semi-annual basis that covers how threat actors break into cloud environments as well as what they're doing once they're in there. While this isn't solely on the serverless side, I do think there are some valuable nuggets for us to draw from for this component. Unfortunately, the text here is very small. I apologize, I didn't double check that in advance. So I'll just read out a couple of the components that I want to make sure to emphasize. When we look at how threat actors are breaking into cloud environments, the most common ones are credentials. I'm not sure if you can read that at all, but it says weak or no credentials. You can just trust me on that. Or you can also check out the report. And misconfiguration up here. So between those two, almost 75% of infections in cloud environments are a result of one of those two issues. This has, I think, direct implication in the serverless space. Because when you're thinking about applications, these two issues, misconfiguration and credentialing issues, both ultimately come back to the challenge that applications could be taken advantage of as a result of not being properly configured or not having sufficient identity management processes in place. And as a result, that could allow for threat actors to be able to take advantage of vulnerable services that are being hosted in the cloud. So while this applies across cloud environments, specifically for serverless, I think these findings would likely be also true for serverless specifically. What I really care more about here, though, is the impacts. When we look at threat actors breaking into cloud environments, what are they doing? The red box over here on the far, wait for it. The red box over here on the far right side highlights that crypto miners accounts for over 50% of the activity we see once threat actors break into cloud environments. So once they're in there, crypto miners are dropped left and right. This isn't terribly surprising because as a threat actor, if I'm looking to make quick money, the easiest way for me to do that is with a crypto miner. It immediately converts my illicit access into cash. I don't have to negotiate a ransom. I don't have to try and engage in some complex third-party scheme. I can just get some money, and that's exactly why I'm here, so it's a great way for me to turn this around. We also see a lot of lateral movement. I keep hitting the next slide button or the laser pointer. We also see lateral movement attempts where threat actors try to take advantage of initial access to then move into another organization, which has sort of a dual party harm, both harm to the party that is now attempting to be accessed, as well as reputational harm to the initially accessed organization, which sort of exponentially increases the harm as you go down the line. The reason I think these things are relevant and important for serverless is that crypto mining being a key endpoint objective for threat actors over time will continue to be a major thing for serverless as well. It's a very obvious way for them to take advantage. But I also think it's important for us to realize that threat actors aren't solely doing crypto mining. This isn't solely about them trying to burn out your compute resources or trying to run up your budget, but also they could be taking advantage of this to be infecting other organizations or other parts of your organization. And that's a potential risk that could increase the overall impact of an infection. All right. Let's talk a little bit how threat actors are shifting tactics over time. So when we're looking at threat actors, there's a few key tactic shifts that I want to highlight. And this also comes in line with why we're talking about serverless today. When we look at the first thing here, talking about shifting from client-side to server-side exploits. 3 years ago, if we were talking about threat actors and we were talking about how they were breaking into environments, phishing emails would have been the thing, right? We all would have been talking about phishing emails and that would have been it. Because what's the weakest link that we all know in the chain of cybersecurity? The people. The people. Okay, we'll work on that. We'll practice that for the next session. But it's what we were all talking about. But a few things have changed in the last 3 years. First off, people are actually getting smarter, which is great. We're seeing users are learning. All this education is finally paying off. High fives all around. Great job, cybersecurity professionals. Additionally, technical controls are getting better. We're seeing more efficient weeding out of potential taking advantage of human users. And we're seeing that phishing emails are being blocked before they actually reach people's inboxes. Links are being stopped before they actually get to connect out and pull down malware. So client-side attacks are becoming increasingly ineffective for threat actors. So we're seeing this interesting shift of threat actors now going to target server-side and exploiting server-side components. Rather than going after users and humans, let's go after vulnerable services that may not have a proper identity access management in place, or go after services that don't have proper restrictions put into place to prevent me from being able to take advantage of their openings. And by doing that, I don't have to worry about all these things, these new protections we have on the human side. I can just take advantage of existing exploitable server-side components. It's nice from a threat actor perspective because you don't have to worry about interaction. You don't have to worry about people. You can just worry about bits and bytes, which ultimately are a lot easier to predict than humans. So that's been a really interesting shift, I think, over time. We're also seeing a real change in the prioritization of threat actors into data exfiltration rather than data encryption. So historically, if a threat actor broke into an environment, what we'd see is they would break in, encrypt everything, and then sell back the decryptor. We've seen a lot of talk about that already today, especially some great talks at the keynotes this morning. But more recently, threat actors are realizing this is a pretty dicey marketplace to be engaged in for a few different reasons. Decryptors, it turns out, are really tough to make. Making good decryptors is even tougher. And so as a threat actor, it takes a lot of time and effort for me to do that. But telling somebody I'm going to post your stuff on the internet unless you pay me $50 million is really easy and really cheap for me to do. So as a threat actor, it makes a lot of sense that I'm shifting in that direction. Additionally, we're getting more security controls around encryption, decryption, and we're getting more security controls as organizations around reconstitution from encryption events. So that's something where, from a threat actor perspective, they're getting less payments as a result of that. But we still don't have a really great solution to having your IP leaked on the internet. So that's something where that still will pay the bills from a threat actor perspective. So from a threat actor perspective, I think we're going to continue to see the shift over time of moving from encryption to exfiltration, because it's much faster, it's much easier, and it's much cheaper for them. So why wouldn't you do it? And if you're going to get paid more often, that's ultimately the goal. And then we've also seen abuse of public cloud storage. This is something that I think is really near and dear to my heart, obviously, working for Google Cloud. But threat actors like to be able to use public cloud storage as a way to sort of stage and host their malicious activities before engaging in them. It provides a veneer of respectability to their malicious activities. Because if you're an organization that normally interacts with a number of different cloud providers, and you see in your network traffic a slightly anomalous piece of activity, but going to one of your cloud providers, you're probably going to say, oh, okay, maybe Joey was just working super late that night and he decided to do something. Whatever, not a big deal. Or if you see that your application is interacting with a public cloud service provider in a way you weren't expecting, you just kind of say, oh, okay, well, maybe they changed something, let's move on. That veneer of respectability and reasonability is what threat actors take advantage of by being able to abuse public cloud storage to help evade detective controls and maintain their longevity in organizations, which ultimately leads to longer tails on incidents and greater harm overall. I think these are some very, I guess I'd say, exciting and worrying trends that we're seeing in threat actor activity, and I'll be interested to see how it continues to develop over time. Okay, so we talked a lot about sort of the general landscape and some of the trends that we're seeing in threat actors, and I've tried to sort of capture how these things apply to serverless. But let's dive into serverless with a little more detail and granularity here. How are threat actors targeting serverless infrastructure? I'd say the number one thing that we've been observing is insecure coding practices leading to major issues here. As more and more organizations are engaging in serverless activity and using serverless architecture, we're seeing more and more functions leading to more avenues of risk. Essentially, the bulk and collection of more and more functions operating within the serverless environment. Again, big business advantages here, so don't want to be dunking on serverless because it's really, really valuable and provides a lot of good benefits overall. But the thing that you have to keep in mind while approaching this is that as you increase the number of functions being brought into a serverless environment, you are also increasing at a high rate the potential loopholes or pitfalls that you might find across code and having insecure coding practices across the board. And there's also sort of a downstream effect here of insecure coding practices within one set of serverless applications. If it's being used as a basis for subsequent iterations, can have more impacts further down the line. So there's more avenues of risk potentially from insecure coding practices over time, and it sort of branches out, leading to larger and larger footprints for organizations. There's also a concern around software supply chain attacks. I mean, this has obviously been in the news quite a bit recently, where we've seen major repositories, major libraries being poisoned in a variety of different ways, and a lot of negative impacts as a result. I think this is something that's going to continue to be a significant driving factor for threat actors over time. We had one major event of it just in the last year where everybody heard about it. They saw how effective it could have been. That sort of event is something where threat actors key in on that sort of activity and realize that this is something they could take advantage of themselves. It's also, I think, an area for a good growth area for a lot of organizations, because I think there's been a real basis of trust for software supply chain for a long time, and there's been a lot of challenge of being able to have that sort of software bill of lading or idea of, where's all your software coming from, really effectively integrated. And I think this is something that's going to continue to be a major issue for the next couple of years. And when we're looking at this from a serverless perspective, if the issue here that we're concerned about is that you could have downstream negative impacts as a result of having malicious code injected into your serverless application, this is clearly going to be a major component that we have to be concerned about as well over time. Finally, the misconfiguration of hosted services and architecture. Misconfigurations has always been an issue. It's a perennial challenge where making sure that you have sufficient configuration controls in place such that only people who are supposed to be able to access your application are doing so, and the people who are leveraging your application have the proper permissioning to do so and are accessing what they should, has been a challenge for organizations for as long as I can remember. And the big thing with serverless here is now we're doing it at a much larger scale. This has been an issue. Misconfiguration of applications has been a challenge for a while, but now that we're able to scale this out to the nth degree, the risk here is that threat actors could take advantage of that to be able to get even larger chunks of information, be able to take more valuable or more significant information from an organization, which would ultimately lead to more harm. And I do like this line: computing scales, but not compliance. It's easy to scale up and build up your computing resources and build up your computing capabilities, but it's not easy to build up your compliance regime around that. So as more and more applications move serverless, and you have to make sure that you have effective compliance controls in place, that becomes increasingly challenging because compliance doesn't scale super well. We haven't really come up with a great way to ensure that applications are compliant with our requirements, short of hiring more people or making those people work overtime. But there's not a lot of people out. There's not a huge pool of people just dying to do application compliance capabilities for very low prices. So for organizations, I think this is going to be a real challenge moving forward. Got the right button this time. So that's how threat actors I could see breaking into and initially taking advantage of applications hosted in serverless environments. What are they going to do with it, though? And I think this is kind of the more interesting part, right? So, okay, a threat actor is now taking advantage of your serverless architecture. Well, what's the worst that could happen, right? How bad could it be? I think this first one's probably one of my least favorite scenarios: delivering communication with malware, right? So delivering malware and communicating with malware from a serverless architecture would be pretty bad for a few reasons. First off, from the organizations that's subsequently targeted by the malware that's being potentially hosted in your serverless environment is going to be a little peeved that you're hosting malware that's targeting their environment too, right? So you're going to look like a real jerk. Additionally, you're essentially providing infrastructure for threat actors for free, which is a real bumskis for trying to stop threat actor activities. That's a technical term, by the way, bumskis. And also, it's generally just detrimental. I'm not sure how much I need to really go into this. I mean, if you can't really see why having your environment delivering and communicating or providing communication infrastructure for malware is a bad thing, see me after the talk. I'd be happy to go into more depth on that. Hosting and directing users to phishing pages, this is one that I think is, this is kind of the classic use case. I think this is like the quintessential concern here, where threat actor takes advantage of your infrastructure, and then they slap a phishing page up on there and say, hey, please put your credentials in here. This has been done since the beginning of time. It's a very classic quintessential case. I think this is not as effective for threat actors right now, because I think that users, as noted, are getting better about this, and credentials are becoming increasingly less helpful. But I wouldn't say that it's the least harmful case that we can imagine. And again, if they're taking advantage of your environment, now you're the one providing them with that veneer of respectability that we were talking about before. And you're the one who's saying, oh yeah, this is totally legit. Don't worry about this network traffic. That's not a problem. I'm sure it's totally okay. And so again, we don't want to be the ones making this job easy for threat actors. And then, of course, they could just attack you, right? Run and execute malicious software in your environment, which could have a whole host of negative implications. It's probably a crypto miner in all likelihood, so you just have to pay a bunch of money, so that's a bummer. But it could also be any number of other potentially malicious activities. They could be, if they're going for more of a low and slow approach, they could instead be executing something that's meant to dig deeper into the organization and cause larger, more wide-scale harm, rather than just a big smash and grab like a crypto miner. So obviously, threat actors abusing serverless architecture is not great. So that's why you don't want that to happen. We're talking about one quick case study here, just because I think it's interesting. This was a case study that we had where, so first off, there's a caveat in the world's smallest font down here. My goal was to get the fonts as small as possible by the end of the talk, so people would wonder what was happening. In this particular circumstance, we have an attacker that's already in the environment, in the cloud environment for an organization. So go into it with that assumption in place. But what had happened was we had an engineer that had an application that needed buckets to store data in pretty reasonably. And the engineer did what any good engineer would do. They made the buckets in a sequential order that made sense. So it was project ID 1, project ID 2, project ID 3, and they made some number of buckets to store data in. And the threat actor observed this and saw that they couldn't get the data out of those particular buckets because, in what was great turbo events, those buckets were properly permissioned and the threat actor couldn't gain access to them and didn't have the credentials they needed. So hey, big thumbs up. But the threat actor was creative and persistent, and they said, well, we're going to make buckets project ID 4 and project ID 5, and I'll say that I have permission for those two buckets. And as noted, scaling is a great capability. It allows for you to do things as long as you need to, for as much as you need to. Once the application finished up with buckets 1, 2, and 3, those buckets were filled, they didn't want to take any more information in. The application looked around and said, well, I should probably logically make a bucket 4. And then looked and said, oh, bucket 4 is right there. How convenient. And so it started putting data into bucket 4 and bucket 5. And the threat actor was able to then take that information and exfiltrate that data back to themselves from buckets 4 and 5, circumventing the existing permissions that were in place and permission controls that were successfully implemented for buckets 1, 2, and 3. It was a very clever and cheeky method for the threat actor to be able to circumvent what was otherwise a well-implemented system. Now, technically, the way you'd get around this in the future is by using a specific set of domain-based bucket naming that would restrict who could actually create buckets within the organization, and you'd have specific permissioning for bucket creation. That was the theoretical pitfall here. But I think this highlights a couple things. One, how an organization that seems to be doing everything right? I mean, they nailed a lot of things here. They got the fact that one guy should be making buckets. They got that the application should be automatically sending those buckets. They got that the application and the buckets were both pretty well secured down, so the threat actor couldn't just pull out information from those. I mean, that sounds like a lot of things going right. But it also captures how one minor quibble, one thing going wrong, could then lead to an insecure state for the organization, and how we have to look for this within a compliance mindset to make sure that we're completely considering all these edge cases. So I think that's pretty neat. I think the other thing here is it highlights how application scaling is a really, really great benefit, but there are also risks that need to be considered when you're looking at implementing things into a serverless architecture so that you have every component really thought of from a security perspective and from a red team perspective and mindset. Another case that we had where we had threat actors leveraging serverless architecture was where we had Astaroth Info Stealer, also known as Pineapple, which is where the cool graphic over there comes from. This was kind of interesting because we had Google Cloud instances and projects being used to generate URLs. So this was a situation where it looked like the threat actor looked like they were making legitimate Google Cloud serverless domains, but they were actually being used for threat actor purposes. Thankfully, we caught this. Attempted spam campaigns were blocked on arrival, so we were able to prevent this in advance. But I think that if we break down sort of what the threat actor was doing here, where they take advantage of a cloud environment and they get into the serverless architecture, and then they say, okay, quick, generate some URLs that look legitimate and use those for a phishing campaign. It's this nice combination of veneer respectability, because this looks like legitimately generated URLs, combined with targeting of vulnerable users to be able to try and gain access to an organization. being able to leverage taking advantage of multiple levers of persuasion, both technical and human, I think is sort of where threat actors will be going to be able to get into organizations into the future. And I think this is a great kind of a quintessential example of this. The last point here that quickly adapts tactics, this is a longstanding threat actor that we'll be continuing to track over time. And I think that what I wanted to highlight here is just because this particular moment wasn't successful doesn't mean that this formula or this recipe of taking advantage of a serverless break to be able to then use that against a human, to then be able to use that to gain initial access into an organization, those sort of abstractly could still be done in a lot of different ways. There's a lot of ways to slice that pie. And as a result, we could see that continue to come up in the future in different ways. Okay, well, I can tell you're all terrified. You all got kind of a scared look on your face, or at least a look that says we're excited for the next snack break. Thanks for one laugh. I'm trying up here. So in terms of mitigations, what can we do about this? We've talked about a couple of key issues, right? Compliance is a big issue. Making sure that serverless applications have code review is a key issue. But I think also what I'd look at here is when we're looking at identity access permissions, least privilege is absolutely critical. I know it's been talked about. I was talking about the keynotes. I'm sure you've seen a few of your sessions. But least privilege is a critical concept that needs to be applied for identity access management, and that applies as well to applications that you have hosted on cloud services. Just because you have your application hosted in cloud services doesn't mean that you can just set it and forget it. You also have to care about this as well and take a look and make sure that you are applying best practices as much as possible. This second one here, prevent easy access to organizations by monitoring for leaked passwords in public repositories. This is one that I really wish I didn't have to say, especially in 2024, but I still do and I still will. Passwords being leaked in public repositories is a surprisingly frequent thing, and I say passwords, but really this applies to any sort of secret key sort of information. This is a pretty common, I'll say a pretty common issue for organizations across the board. This is easily searchable. This is something that organizations should already have programs stood up for and should have compliance capabilities to make sure that this isn't happening. If you don't have these capabilities already sort of put together, please consider doing so. And if you don't know how to do it, come talk to me after this. I'd be happy to help direct you to some resources. There's lots of ways you can look into this sort of information, but this is something where we shouldn't keep seeing this problem. Even if there are secret information being leaked in public repositories, organizations should be aware of it faster than threat actors are. I think that's something that we could all work together. My hope is next year we'll never have this conversation again. Having detective controls in place for cloud-related and malicious activities, this is to try and get underneath that veneer of respectability. I think organizations need to make sure that just because something says it's going to a cloud environment doesn't mean that it's auto-trust all good to go. You should still be looking into that, investigating that, and having detective controls in place for anomalous activity between your organization and your cloud environments. This is something that I think is necessary to prevent usage of cloud as a veneer of acceptability. And leveraging tools native to your cloud environment is, this is just a little side note, a little tangent, but organizations sometimes when they're doing these investigations or doing detective controls don't necessarily use tools that are native to the specific cloud environment. And the risk there is that if your tools aren't as familiar or comfortable with the cloud environment, they won't be able to search or detect as effectively. So having things native to the cloud environment that you're using, I think, is a much more effective scheme and approach, or in my experience at least. Finally, and this is one that I think everybody should just go home and do. If you're looking for like one easy win when you get back from the conference and you want to tell your bosses, hey, I did one thing as a result of this conference, this is my recommendation here, is institute alerting for spikes in traffic or activity. If your compute bill goes above X dollars, you should all get an email. I mean, it's one of the easiest things to implement for almost every major cloud provider. There's a box you press that says, if there's an alert, if this goes above X dollars, send me an alert. Everybody should have that implemented. Anytime I don't see that implemented, I say this is the easiest way for you to make sure that you will detect crypto mining activities, at least at a reasonable pace within your organization. Because if somebody's taking advantage of your serverless architecture and they drop a crypto miner, I can almost guarantee you that they will spike traffic so high that this detection will go off and say, hey, something's wrong. So if you don't have that detection in place, you're missing out. And again, this is extremely low lift. Fun fact, you can also probably do this for your mobile provider too, so that's also good to make sure you're not spending too much time on watching videos of cats or whatever. So that's a good way to minimize your cell phone bill. But this is a really easy one. And also, anomalous network traffic alerts, this is again to get past that veneer of respectability where we want to say, just because it's going to this organization or just because it's going to this particular IP address doesn't necessarily mean it's good. We should be investigating everything as if there is some potential malicious activity behind it. So give it a little more scrutiny and don't just give things a free pass. And that concludes my talk for today. I'll open up for questions. Thank you all so much for coming. Yeah, go ahead.
Any idea what type of crypto they're mining? I mean, there's no GPU attached to most Lambda functions or serverless cloud functions.
Yeah, it was since it was an XMRig miner coming in there, it'd be Monero. Yeah, which also makes sense based on the type of, because it's CPU versus GPU, right? So it's, and also being a privacy-based cryptocurrency, it was a very effective way for them to be able to get the money and then leave with it without any sort of tracking mechanism put in place. And if anybody wants to go really in depth about different types of cryptocurrencies and which ones are best for criminals, again, find me after the talk, but I'm not gonna put that onto a recorded session because I'm not giving them any help. Figure it out yourselves. Yeah, go ahead.
Yeah, so you chatted earlier about how there's a trend moving from encryption to data theft and then extortion. But it seems like a lot of the malware we see in the cloud, from what you were talking about, is crypto miners trying to use cloud computing resources. Do you think we will see a day where threat actors are stealing data for extortion from cloud environments?
Yeah, I think so. I think that, and to get sort of to your first point there, I think this is a matter of quantity versus, I don't say quantity versus quality, but it's a quantitative issue. We're seeing crypto mining most frequently, but that doesn't necessarily mean that it's having the largest impact. We're seeing lots of crypto miners being dropped, but those are what I'd call smash and grab activities, right? Those are things where threat actors break in, and they don't care how much noise they're gonna make. They'll only be there for a number of hours or a number of days before they get kicked out, and then that's it. Whereas with these exfiltration activities, these tend to be longer form activities. So we may not see them as frequently, but when we do see them, the level of impact can be much more significant. So I think that sort of speaks to why we see that discrepancy. To your second point about exfiltrate, will we see exfiltration of data from cloud environments? Absolutely. I think when it comes down to it, organizations across the board are moving into cloud environments pretty significantly, and I think threat actors have observed this trend over time of organizations moving over to cloud environments and are tailoring their approaches accordingly. And I think as we continue to see more and more organizations transition into the cloud, we're going to continue to see threat actor targeting of that with the intention of being able to exfiltrate critical data. And we've already seen this from a number of exfiltrations from misconfigured databases that are openly available that were being hosted on cloud services. And I think this will be something that we continue to see into the future. Great question. Any other questions? Oh, one in the back there. Let's chat about. I'd love to talk with you more about that after the talk here. I think it's just it could be a pretty lengthy thing, and also kind of depends on the organization. So I'd love to have a conversation about that. That sounds all right. Thanks, appreciate it. Yeah, go ahead.
One of the challenges that we go through with serverless in the sense not just to
I'm so sorry. Could you speak up just a little bit? I'm just having a little trouble hearing you. It's just.
Sorry, I'm kind of.
No, that's totally fine. I'm very loud, so I have the opposite problem.
All right. So one of the challenges that we go through with serverless environment is that, because of the malware issue, so whenever we connect the serverless environment into our network, we usually want to kind of dedicated, IPs or whatever, so that we can, connect to our network and we can make it to go through our firewall. Mm-hmm. But the problem is we are not getting the dedicated IPs. We are not, for example, if it's Azure, we are not getting dedicated VNet. AWS, we are not getting dedicated VPCs. So because of that, application teams, they want to kind of higher performance, they want to do everything there. And what's the issue with that? That kind of question. But network side, network security side, we want to make sure that anything comes from outside has to go through our firewall. Mm-hmm. But in this case, we are not able to set up any specific fence around our compute environment there? Is there any solution around it? 'Cause recently, Databricks side, they kind of implemented a control called network config. So what they do is they'll attach to that compute environment so that whatever computes we create there, it all will connect to that network connect config. And then from there, we know where the communication is coming from. So I'm wondering about, AWS side or even in Azure side, is there any kind of such control there where we can actually put a control on our firewall to make sure that it is coming from out? Because we don't manage those computes.
Yeah, and that's a great question. I can't speak to that specifically because it is a good, what I'm understanding is it's a good architectural question of how you can best, what controls or architecture you can put into place for that. I can't speak to that at that level of depth currently. I'm mostly focused on threat trends and how threat actors are targeting this environment. But I think we could definitely find a way. I'm sure there's lots of folks who could speak to more in depth that, but that's a little bit outside of my area of expertise.
That's okay.
So it's a great question, but I'm sorry, I can't.
That's the
I don't want.
challenge you have been going through. So.
Yeah, no, it's a really interesting. I appreciate you explaining it to me, and unfortunately I can't go to that level of depth, but it's a great question.
We have a lot of experts in the Google Cloud security demo area at the expo floor. We have our sales engineers also there, so I'm sure somebody would like.
I wasn't sure if I was allowed to reference the expo from up here, but yeah, I think there's lots of people up there who'd be happy to, who'd be able to dive into that. Any other questions? Go ahead.
Actors using serverless architecture as like command and control or persistence?
Not as much as you would think so far. Usually they're using, serverless hasn't really been a great venue for C2 at this point because it doesn't really provide any unique benefit to them to be able to get into that space. They're using other elements of the cloud environment instead for C2 operations. Could they? I don't see why not offhand. I think the rationale though is that from their perspective, they have existing mechanisms that work just fine. Why would we invest in that? I think if we start seeing a clamp down in other spaces, it could be a potential avenue in the future, but we're not seeing much of that activity currently. Yeah, great question. Yeah, in the back.
Since these serverless environments are typically hosted by big companies, right? They have capability. You mentioned native cloud tools to set alarms and alerts and things. How are those robust enough? I mean, is that just another console that our threat hunters need to watch, or are you seeing companies successfully bring those IOCs into like SIMs and SOAR platforms for more 24/7 alarming and alerting?
Well, I mean, I would say that at least one company has one of the best on the market, and it's very, very good. But no, it's a great question. In my experience, I think we are seeing actually very significant impacts as a result of this native tooling. And I hear what you're saying, right?
Is it enough? I know they have them. I mean,
Yeah.
everything.
Is it enough? And that's I guess to some extent a bit of a philosophical question, right? I think I would say it's a significant step forward. I think it is. I would say that the console is one aperture that you're looking at for potential detective controls, but that's simply detective, right? And we think if we all get our CISSP study hats on, there's lots of different control vibes, right? We could also look at preventative controls in the compliance space, which wouldn't necessarily be covered there. We can also look at reactive controls of, okay, if we do see issues, how are we going to make it so that we have alerting come up as well? So I think that, is it enough? I think it's a very effective methodology and a very effective tool you can use to help with detection and alerting. Is it the only step you should be taking? I don't think so. I think there should be a more broad regime or regimen than that. But if you can only afford one thing, or you only have the resourcing to be able to do one thing, I think it could be pretty darn effective. And since it's already natively built in, hopefully pretty cost effective for most organizations.
So these clouds, I like what you said about cloud cost control. And if your costs or compute seems to be spiking, people sending that type of data to their SIMs too as for correlative analysis, or
I think it depends on the organization. If I'm being honest, when we look at from the incidents I've seen with crypto mining, you wouldn't even need to send it to your SIM. The amount, it's not like the crypto miners are spinning up like 5x of your usual monthly spend, it's like they're spending up 10,000x. I mean, it's orders of magnitude more compute power than an organization would use. And so as a result, it's something where you could send it to a separate system to alert on it, but there's no real point. You can just send it straight to a user because you could, yeah, essentially it's like, this is such a big deal, you don't have to send it to a console. You need to send it like straight to someone saying, hey, this needs to be stopped immediately. Does that make sense? It's pretty nuts though. The amount they could spin up is pretty significant in a very short period of time, but that's the double-edged sword of scaling capability. Great questions. Any other questions here, team? Yeah, in the front.
So you mentioned at the beginning about the client versus the provider, finger pointing at who's at fault. Client serverless instance gets compromised with some kind of crypto miner. You went and mentioned it's like 10,000x.
Mm-hmm.
So who's responsible for the bill?
That's a great question. I don't know that I can say concretely the answer to that. I would probably say I need to talk to a lawyer. But, because nice try though, but no, I'm not getting on the hook for that. No, it's a great question. I don't know the concrete answer to that. I think the technical answer would probably be, well, it depends on the nature of your contract and your terms of service and what exactly was all written out when you signed the dotted line. But I'm not sure, and I'd hate to speculate too much on that one. But it's a great question.
I will plug for the Google Cloud side. There is a crypto mining protection program, so I would encourage you to go check it out. It predominantly lays out where we could help, how we can help, if something of that sort happens. But it's a program in itself that somebody needs to subscribe to.
Very cool. Thank you.
I'm not sure if I'm allowed to say stuff like that up here.
Oh, I see.
It is an interesting program, though. I recommend checking it out. Oh, okay, you can say that. Great. Okay, cool. Yeah, I'm just a threat intel guy, so I'm not. Great questions so far. Any other questions? Hey, well, thank you all so much. Appreciate you coming for the talk today. Enjoy the rest of your day and tomorrow here at MWise. Thank you so much.